In this video, we will develop formulas for the derivatives of natural log of x and log base a of x using implicit differentiation. For natural log x, we're going to use the fact that the derivative with respect to x of e to the x equals e to the x. Let's start by taking this natural log here and thinking of it as base e, and let's rewrite it in exponential form. We start with the base e, raise it to the power of y, and set it equal to x. If that's not familiar to you, you might think of exponentiating each side with base e, where e to the natural log cancel, leaving you with x, because they are inverse functions. Next, we'll take the derivative. Derivative of e to the y is equal to e to the y, and then you multiply by chain rule the derivative of y, which we will call dy dx. There's our implicit differentiation step. Derivative on the right-hand side of x equals 1. Let's solve for dy dx. We can do that by dividing by e to the y on each side, and then a substitution step. Y equals natural log x. Dy dx equals 1 over e to the y, where we are replacing y with natural log of x, and e to the natural log of x is equal to 1. So this derivative becomes dy dx equals 1 over x. E to the natural log of x becomes x. So we developed a formula here where the derivative with respect to x of the natural log x function equals 1 over x. Next, we'll apply the same thing to log base a of x. We need to make use of the fact that the derivative with respect to x of a to the x is equal to a to the x multiplied by natural log of a. Let's rewrite exponential form for this logarithm. Base a to the y is set equal to x, or you can exponentiate base a because base a to the log base a cancel, being inverse functions there. And then the derivative step. The derivative of a to the y equals a to the y natural log of a, as our formula in the top right corner shows. But you have to use the chain rule still, multiply by the derivative of y, which we'll call dy dx. And on the right-hand side, the derivative of x equals 1. Let's solve for dy dx. And we will divide each side by a to the y natural log of a. And then we have a substitution step. Y equals log base a of x. So we have dy dx equals 1 over a to the substituting y here as log base a of x. Don't forget to multiply by natural log of a, where a to the log base a cancel. That leaves us with the x. So rewriting what we have here, dy dx equals 1 over x natural log of a. So we've established the formula. The derivative with respect to x of log base a of x equals 1 over x times natural log of a.